welcome back to my channel. In today's video, we'll be talking about the different types of linear functions. So before we get started, let me first introduce some forms of linear functions. So the first one is, I think almost all of you already know this, called slope-intercept form, and that is essentially y equals mx plus b. The most typical linear function that everyone uses. So for those of you who don't know what that is, m represents the slope, b represents the y-intercept, and then there's the point slope form, and that is equal to y equals to m bracket x minus h plus k. And for those of you who don't know what that is, some of you may know that, oh, this kind of looks like the vertex form of the quadratics. So remember, vertex form in quadratics is y equals to ax minus h squared plus k, where the vertex, you can see that the vertex is going to be h comma k. So the h represents the horizontal translation, and then the k represents the vertical translation. And so the same thing applies to the point slope form here. The h is a point and then the k is the point. Now I know there's no like vertex in a linear function, it's just a straight line. So the point h comma k is any random point in the linear, which is very, very, very useful when you have graphs that don't clearly show the slope, but you can clearly see a point, and then you can solve for the slope from there, which we will work on it later. And then finally we have the intercept form, or to intercept form. And from the word, you can already guess that it shows two intercepts, right? It shows the y-intercept, it shows the x-intercept, and it shows the y-intercept. So here, just by looking at this equation here, you can see that x over a plus y over b, and essentially a is basically the x-intercept, so it would be a comma 0, and then b would be the y-intercept, so 0 comma b. And so, which is why this is called intercept form. Oh, there's also one more that we may not use for this practice here today, but this is also useful. This is called standard form. Let me write the name first. It's called standard form, and this is useful when you want to kind of change the form back into slope-intercept form, but it doesn't clearly show the y-intercept or the x-intercept or any point. But you have to keep in mind that A and B and C, they all have to be integers. So that's a rule for standard form. Now let's apply these to these questions. So, given the graphs, write the equation for the lines. Choose nice integer value points when writing the equations. So it says nice integer value points. So what that means is you don't want to pick a decimal point. So look here, we know that this is 1, this is 2, this is 3. We don't want to say 3.5. We want integers, so that's easy. And so here we want to use one of these forms that is the most easy to apply for this graph. So for the first one, you can see that we can't really see clearly the intercepts, so we don't want to use intercept form. How about slope-intercept form? Let's see. So again, for the slope-intercept form, remember it's y equals to mx plus b. The b is kind of hard to see because it is a decimal, so we don't want that. So our last option is probably point slope form. So y equals mx minus h plus k. So here we can find any random point here, and we can just plot h and k in already. So let's see. Oh, I see here this is a pretty solid point, and it looks like this is 1, 2, 3, 4, 5. So 5, comma 1. So I already know what h and k is. H is -5 plus 1. So remember, like we said before, don't be confused with the negative sign here because it's negative. So x minus, we know that h is 5. So it still has to be a negative number. So just keep in mind, whenever you see the h and k, people tend to always get confused with the h. So remember, it's -5, even though the point is 5, 1. Alright, so we already know the point here. Now we just need to fill out what m is. So in order to solve for m, we can also find another point that is a solid point. So would this point work? No, because it's kind of in between. You don't want that. You want a nice integer value. So it looks like this is a point here. That is 2, -1. So I know that the slope would be, remember, in order to find the slope, it is change in y over change in x. So the y value here is 1 minus -1 over 5 minus 2. And so you can also do the other way around and do like -1 minus 1 and then 2 minus 5. But in order to make it easier, you usually want the slope, the point that is bigger. So 1 minus -1 is 1 plus 1, which is 2. I'll write here. 2 over 5 minus 2 is 3. So you know that the slope is 2 over 3. And then we can plot that in here, which becomes y. Let's leave some space for later, which becomes y equals to 2 over 3x minus 5 plus 1. And there you have it. We have our point here. We can see very clearly that we have the point 5, 1. So moving on, let's try this one here. So I can see that the y-intercept is pretty clear. However, the x is kind of not a solid integer point. So we don't want to do intercept form. We can try slope intercept form. Does that work? It looks like it works because I can find the slope easily, and then I also have the y-intercept clearly. So I know y equals to mx plus, that is 2, because this here is 0, 2. And we can also find another point that is clear. We can try this point here. This one seems clear. Or we can also try this point or this point. But then you can kind of see the pattern here. It goes down 3 and then run 1. So it goes down. So I know that I know the slope is negative because it's going downwards. And I know it's -3 because look, 1, 2, 3, run 2. So I can do that. Or you can also do this method here where you want to have the point -1, 5, I believe. Yeah, we can do that as well. But the most easiest point is just do this because you know it's rise over run, so 3 and 1. So I know this becomes y equals to -3x plus 2. Moving on. So here, this time I can clearly see the x-intercept and I can also clearly see the y-intercept. So that means we can use intercept form. So I know that the form is this. Oh wait, sorry. Y over b equals to 1. Let's double check. Yep, so that's our form. And remember, the a represents x-intercept and the b represents the y-intercept. So we know that the x-intercept is 1, 2, 3, -3 plus y over b, which is 1, 2, 3, 4, 5, 6. 6, -6 equals to 1. And you can also simplify it to y equals to x over -3 minus y over 6. So that's clear because this one is negative and positive negative becomes negative. So yeah, there's our simplified version. And for the final question, so this one is a bit different compared to others. We see that they're distinct points, but it says that it is linear for the line, so it's linear. So again, we can choose which form should we use. So for this one, there are multiple ways to do it. I would personally want to do it. So intercept form, I would not do it because it's kind of hard to see that if that is really the y-intercept, and you can't really see the x-intercept. And then same here for the y-intercept, it's not clear, so I would go with point slope form. So y equals to m, and that is our point slope form, and we can choose any random point. But first of all, let's try solving for the slope. So here we have 2 points that clearly shows the coordinates, so we can use that to find the slope. So again, rise over run. So I would do this minus this, and then over this minus this. Oopsie. So that minus that. These numbers are too big, so I don't want to say it out loud. 150 minus 100. And we get 250 over 50. And we can cross out the zeros. We get 25 over 5, which is the same as 5. So you know the slope is 5. And from here on, I can just choose either this point to put in as h or k, or I could choose this point. Let's go with this one. So again, h is -150. Be careful of the negative sign, plus 11,250. And there you have it. Thanks for watching.